Unit 6, Lesson 5, Part 3. Should be a little bit shorter one just to chop it up a bit for easy viewing. Anyway, so I'm going through the equation of the unit circle, kind of where it comes from, but it comes from the Pythagorean theorem. I'm going to go ahead and make a short video after this even to kind of go in further about the unit circle. But it comes from Pythagorean theorem and the idea of special triangles that have these specific patterns. So the unit circle holds a specific pattern around. But basically, the unit circle is a circle with a radius of 1, and it has x and y coordinates. So simply, for Pythagorean theorem, if you just look at this triangle here, if we want to do Pythagorean theorem, it'd be x squared plus y squared equals 1 squared. So that's the equation of the unit circle. Okay, if you want to take a second, and if you wanted to put in your calculator, I can show you real quick. If you solve for y here, you would get this value. You would get y equals square root 1 minus x squared and negative 1 minus x squared. If you put these into your y value, so y1, y2, you'll see it makes a circle for you, and that is the unit circle with a radius of 1. Make sure if you make your window probably like just 2 to negative 2 and 2 to negative 2, it gets a nice clear picture. But anyway, so the equation of the circle with the center at the origin, use Pythagorean theorem for the equation of the circle with the center at the origin at the radius r. So it just simply wants you to plug in r there for 1. And so this is the equation for all circles. And with center at the origin, so x squared y squared equals r squared. Just to throw something out to you, if I threw the exact same form, so a circle form, but I said it was x minus 2 squared plus y minus 3 squared equals 64, what that means is your center moved. Your center moved right 2, down, or sorry, up 3. You do the opposite still because I know we don't use the opposite for y, but y, that vertical translations, is usually not squared. It's about what makes it 0 inside. Okay, so this would be a positive 2 and a positive 3. This is extra information. You don't have to worry about this too much, but I just want you to understand the idea of how circles can move. So if I just drew this real quick, r squared, so that means my radius is 8. Okay, so this is a circle that's moved right 2, up 3. It's right there, and has a radius of 8. So like way down here, so it'd be a big circle here, looking like that, something along those lines. Okay. So just the idea of circles. I can even tell you about how they stretch to be ellipses sometime. But anyway, so determine which of the following points lie in a unit circle. So the reason I told you that is we can figure out if our point lies in a circle, because if it does, then the x coordinate and the y coordinate squared added should equal what? 1. Okay, so x squared plus y squared should equal 1. We know that if it's on the unit circle. So with that, we're simply going to go, whoops. Off here so it's not blue. Okay, all right, so with that, we're simply going to go 1/2 squared plus 1/2 squared equals 1, question mark. So we'll see if it does. Well, 1/2 squared is 1/4 plus 1/4. That's 2/4. So it does not equal 1. So this one is no. It's not on the unit circle. Okay, these other ones are a little bit easier to do if you calculate. So you're going to go 16 over 65 squared plus negative 63 over 65 squared. Okay, if you put that in your calculator, you got 16 divided by 65 squared plus bracket negative 63 divided by 65 squared. You get the answer of 1, so this is a yes. And you do it this one as well. Negative 2 over 3 squared plus root 5 over 3 squared. Okay, so if you do this one, it's going to be 4 over 9. If you do this one, it's going to be 5 over 9. So you can see that 4 plus 5 over 9 is 9 over 9. So that's a 1. So this is a yes as well. Okay, so that kind of closes the door on that idea. Okay, so then as we get to here to the last couple examples, so example 8. So the point P is at negative 1/5 y. It lies in the unit circle in quadrant 3. Determine the value of y. So the first thing I know, if it's in quadrant 3, x and y are both what? Negative, correct. So we're expecting a negative, negative x and y answer. So to determine that value, I'm going to go, okay, so I want negative 1/5 squared plus y squared to equal 1 squared. And I'm going to solve for y now. So that means that negative 1/5 squared is 1 over 25. plus y squared equals 1. So you subtract the 1 over 25. Okay, so I get y squared equals 24 over 25. We square root, we square root. When you simplify that, y is going to equal 2 root 6. You can take a 4 out. Square root of 4 is 2. So 2 root 6 over 5 is the value of y. Okay, so the point P lies in the terminal arm rotation angle theta. Determine the exact values of secant and cotangent theta. So what we got to do now is we got to figure out, okay, cosine is the x value. So cosine theta is negative 1/5. And then we know that sine theta is the y value, which is what we just found, 2 root 6 over 5. So it wants to know secant. Well, secant is flip of cosine. So secant theta is simply going to be negative 5, 1/5 flipped. Now, cotangent theta is actually going to be, it's actually kind of separate here, because tangent is sine over cos. I have written cos over sine, so it's flipped. So it's these two right here over top of each other. Okay, so cotangent will be negative 1/5 over, this is also, sorry, these are negatives here. I had to put that on there. Those are negatives. Okay, because we're in quadrant 3. So cotangent negative 1/5 over negative 2 root 6 over 5. When you see the 5s there, they're going to cancel. So you're going to, and the negatives cancel. So you get 1 over 2 root 6. We're going to rationalize. And that rationalizes to root 6 over 12. Because root 6 times root 6 is 6 times 2 is 12. So the value for cotangent theta is root 6 over 12. And that's positive. And why that's positive is because that's the quadrant which tangent and cotangent are positive. Okay, determine the value of the nearest tenth of the radian in between 0 and 2 pi. So now we're trying to figure out the actual value of theta. So we can do that for any of these, the cosine or sines. We just simply have to do cos inverse again. Make sure you're in radian mode this time. And you're going to just put 1/5 again, because we'll just put positive 1/5, because that's going to be the reference angle. So when you do that, you get 1.3694. Okay, that's your reference angle in radians. So what that means is what you found in terms of visual, you figured out, so we're in quadrant 3, you figured out this measurement. So we need to add what to it, forget the whole thing. In radians, if you said 180, you're right, but we want radians, so we want pi. So you want to add pi to this value to get the complete. Okay, and so when we do that, it gives us the value of 4.5 radians. Okay. All right. Okay, so here we go. We got example 9, last one. So determine the equation of a circle with a center at the origin and a radius of 8. Okay, so radius of 8, so that would simply be x squared plus y squared equals 64. R squared, 8 squared. Okay. If the point negative 4 b root 3 lies on the circle that you just made, determine all possible values of b. So all possible values, there's a plus or a minus. We kind of know that the circle, they're all symmetric in terms of plus and minuses. So what we're going to do is, we're doing our x squared, y squared equals 64. So negative 4 squared plus b root 3 squared equals 64. And we're going to solve for b now. So negative 4 squared is 16. Okay. B root 3 squared is 3b squared. And then we're going to subtract the 16. So we get 3b squared equals 48. Divide 3, b squared equals 16. Square root, b is plus or minus 4. Okay, so what that means is the values for b can be plus or minus 4. So that means we have the value of negative 4 root 3 as a possible point, and negative 4 root 3 as the other possible point for when your b changes. Now obviously there is going to be those same exact points with positive 4, but they didn't really ask for that. They just wanted the two options for b, 4 and negative 4. Okay, we'll stop there for part 3.